In winter, have you ever rubbed your hands together to make them feel warmer? What is happening when you do that? The kinetic energy of your moving hands is being converted into heat energy due to friction between the hands. This is an example of how energy converts from one form to another. Now, we are going to learn another property of energy. Energy cannot be created or destroyed. This means that although energy can convert from one form to another, the total energy in a system always remains the same. When we rub our hands, the kinetic energy is converted to heat. It is not destroyed. Similarly, the heat energy comes from the kinetic energy. It is not created. However, the sum of the kinetic energy and heat energy will remain the same. This important property of energy is called the law of conservation of energy. The law of conservation of energy states that energy cannot be created or destroyed, but it can be changed from one form to another, and the total energy always remains the same. Let's perform a simple activity to understand the law of conservation of energy. To perform this activity, we need an eraser, a thread, and an iron stand. Let's start the activity. Tie the eraser at one end of the thread. Tie the other end of the thread to the stand like this. Now, pull the eraser to a point and release it. The eraser attached to the thread will start swinging back and forth continuously. Let's have a closer look at what happened in this activity. Let us mark the two extreme ends of the path of the eraser as A and B, and let's name the midpoint as C. In the beginning, when we pull the eraser from C to A, kinetic energy from our hand is converted into potential energy in the eraser. As we release the eraser, it starts moving and the potential energy stored in it changes into kinetic energy. When the eraser reaches point C, all the potential energy stored in it changes into kinetic energy and its potential energy becomes zero. Therefore, the kinetic energy is maximum at this point and the eraser is moving at its greatest speed. Due to this kinetic energy, the eraser continues moving forward. When it reaches point B, all the kinetic energy changes into potential energy again, resulting in zero kinetic energy and maximum potential energy. Due to this zero kinetic energy, the eraser stops momentarily and changes its direction. The above process continues as the eraser moves forward and backward. Let's discuss the conclusion of this activity. The total energy of the eraser remains the same as it moves forward and backward. The form of energy is changing as it is moving from potential to kinetic energy and vice versa. This shows that energy is conserved. But there's another question. Can you tell why the eraser eventually stops swinging after some time, although energy is conserved? What happens to its energy? You're right, Bubbles. Some of the energy of a system changes into unwanted energy. In this case, it will be the heat energy due to friction with air. This heat energy dissipates into the atmosphere and the eraser slows down and eventually stops when all the energy is dissipated. Do you know what would happen if you were to do this in outer space where there is no air? The eraser would go on swinging forever. The mechanical energy of the eraser would be conserved, and there would be no energy dissipation as heat. Let's do an exercise. In the activity performed, can you tell which form of energy the eraser possesses between point A and C? Is it kinetic energy, potential energy, or both forms of energy? Between points A and C, The eraser has both kinetic and potential energy. While moving from point A to C, potential energy changes into kinetic energy, so potential energy increases. On the other hand, while moving from C to A, kinetic energy changes into potential energy. Time to summarize. The law of conservation of energy states that energy cannot be created or destroyed, but it changes from one form to another. In the absence of friction, there is no energy loss, and it can be observed that total energy in a system remains constant.